kick off. Hi, and hi to everyone online. I always find that first bit a little bit awkward. I quite wanted some smoke and lights. Health and safety said it wasn't allowed. And then I thought, well, maybe some rocky music, and my friends told me that wasn't allowed. So we'll just go with hi. Quick note first of all, mobile phones, if you could please take them out and turn them on. Because A, we might need them halfway through, if the demo works. And B, you know, I'd quite like you to tweet like people possessed. If you see something that you like. If you see something you don't like, then you can keep quiet. So, I'm not going to talk very much about the background of Python and PsychoPy. I mean, because probably most of you are a little bit aware of PsychoPy already. But it began with just a Python library. In 2002, we registered on SourceForge as a Python library to run psychophysics. It was really called PsychoPy. So this means that PsychoPy is 16 years old this year. If I get a little bit emotional, be kind. Around 2006, we ended up with PsychoPy 1, which was including, by that stage, an application that you could download, and it appeared in your start menu, and it had a little editor that's now called the Coder View. And PsychoPy 2 was the wave of development where we added the builder interface. And partly, Andre Gauss from York was involved with that, who's here today. So, yeah, that was what has ostensibly been called PsychoPy 2. You might notice we've never had release 2.0. I never quite felt that it was ready. We're jumping straight past that, and we're now on to PsychoPy 3, and today is the launch of PsychoPy 3.0.0 Beta 1. Okay, bear in mind it is still beta software. So how do we go about running studies online? What's this about? The key to this was basically port our Python library, the thing that began all of this, into JavaScript. You can't run Python in a browser, so we needed a JavaScript equivalent, and I don't write JavaScript, so we needed to hire someone for that, and therefore we needed funding for that. If we've got a JavaScript library, well, Builder can output that JavaScript, because Builder already was a graphical device for outputting Python code, so it could just output JavaScript code instead. So that part, at least logically, was fairly straightforward. And the last thing is that we needed a server and repository that would make it easier to launch that study. So that was the third piece that we needed to add. Well, since January 2018, we've been funded by the Wellcome Trust, and that's made all of this possible. That means that we could hire programmers to write the JavaScript and to build the repository and make all of this work. So bear in mind, though, just a few months into that project. Okay, it's a 2-year project, we're 7 months in, hence the beta tag. So, brief bit of information about PsychoJS. Not very much. This is for the tech people. This is written in ECMA script 6, ES6, modern JavaScript, basically. And the critical thing is that it uses WebGL and a fallback to Canvas, for those that know about that. Basically, this is a much faster way of rendering in a browser. WebGL means we can use hardware-accelerated graphics. PsychoPy was always built around OpenGL, and the point of it was that you could manipulate your stimulus in real time. You could change its position, you could rotate it, scale it. The reason you can do all of that in real time is because of hardware-accelerated graphics. When that became available in the browser, all of this became possible. Now, the PsychoJS library is designed to match roughly the PsychoPy classes as far as it can, and currently supports a subset of them, but that's going to grow hugely over the next few months. And it can now output from Builder that JavaScript into a folder, which we'll see in a moment. Builder always had a modular design, so this makes it relatively easy. It does the same thing in JavaScript. We don't need to worry too much about the details of how that works. So here's the problem. We wrote a proof of principle for this a couple of years ago, and one of the big issues is, where do you put it? You know, do you have your own server that allows you to do this sort of thing? Do you understand web permissions well enough to know what the folder is and sorry, what the folder permission should be? Or did you just open it up to the entire world? Probably. Did you know about the PHP script, etc.? So we needed a place to host them to make it easy for someone who didn't know how to handle a server, who didn't have their own security certificates to make it encrypted and secure. We needed something that they could use. Pavlovia. That is the first new thing for you today. So, Pavlovia, I decided to record this in case the internet failed while I was trying to do it. Pavlovia.org, there we go. Pavlovia is the place where behavior is studied. We're big fans of open science, so this is all about open science. Oh, see, that didn't go very well. Oh no. There we go. Maybe I should just go to the live site. Shall I just go to the live site? Let's do that. Let's do. It can't be worse than the demo. It worked fine. All good. So, Pavlovia. It's about open science. We want to provide a place where you can search for studies, where you can share studies. That's the key thing. You want to be able to share if you want to, you can share with the public, and that's ultimately a really great goal. You can also share just with your lab, so you can create users and groups, and you could assign a certain number of users to your lab. You can use this to sync across your machine, so you can upload your project in your office, you can go to your lab, you can sync again, and you'll get your project. Okay, so it's a simple place for you to search and share. It's also a place where you can organize your workflow. So this is a full version control system. It's Git. You're using Git. If you're already familiar with Git, then you can use this to push and pull and merge your work. Okay, how many of you currently have a folder with the latest version of your experiment in capitals, and then it says newer? Yeah, there's a few nods. You could use a thing called a version control system that would allow you not to have to see lots of copies. There would just be one visible copy, and it would do this for you. I'm hoping that some of this is going to help you to use version control. So PsychoPy is going to do that for you a little bit along the way. It's going to use Git and push and pull to this repository. Along the way, you'll also get issue tracking. So you could create issues there that your supervisor needs to check this, or someone else needs to check that. Remind myself to change this file. Those are issues. So there are lots of, you could create wikis on the site, all sorts of things. Everything, if you're using GitHub already, all the sort of things that you can do with GitHub, you can do with Pavlovia. Yeah, there's a question.
Where does Pavlovia come from? Who runs it? How can we trust that in a few years this thing will still be here?
Yes. That's kind of a later in the talk question, but we'll go with it now if you like. We're on slide 4, trust me a little bit. Yes, we'll come on to sustainability, just hold your horses. But here's the thing that's different to GitHub, right? So you could already be using GitHub, you could push your stuff there and do your syncing, and that would be fine. Pavlovia and GitLab, which is underneath it, will also launch your studies, and that's the key thing. So you synchronize your files, you push and pull, and suddenly you can press run again, and you can go and run your new version that you've just synchronized online. So that is the last part. All of this will work with other systems as well. So we will be able to use lab.js or JS Psych if you're already using those open source systems. You can actually make use of those on GitLab and Pavlovia as well. So let's have a look at a few things. We could go and explore some studies, but I'm going to sign in first. Oh, I'm already signed in. There we go. When we sign in, we find a number of public studies, but also the studies that I own. I don't want to see the private ones, let's just look at the public ones for now. And we can go and have a look. We could view the code, which would take us to that GitLab interface. We could look at the commits, which was the history of this project essentially. If you'd rather not worry about those sorts of things, PsychoPy is going to take care of those for you as well. But we could also go and press run, and we can go and start running our study. Okay. Test. Okay. And we've gone into full screen mode, and we're doing the Stroop task. Right. So, Pavlovia, in a nutshell, for technophobes, you're going to interact with this probably mostly just through PsychoPy. And you won't really need to go to the site very much at all. That's going to make things fairly easy for you. For those of you who like the technical stuff, you've got full GitHub type features there in the background for you. You've got your full Git workflow that you can use straight from your terminal if you want to. So as I said before, it's not going to be just for PsychoPy. Right now, it is just the PsychoJS experiments that are running on there, but JS Psych and lab.js will also run there. And if you've got your own other library that you need us to work with, we'll be able to do that. We're really confident that that's going to be working very soon. In essence, what you need to do to run a study is you have an HTML folder within your project. When you sync, you can then press activate. That HTML folder becomes essentially a live website, and the extra parts that we need are in order to save data and that sort of thing. When you press activate, it will set up the necessary files for you to save the data onto the server. When that data is saved, it's then pushed back into your repository if you're using flat CSV files. So we'll look at that in a minute. Okay, searching for and fetching studies. So this is now within PsychoPy. We've actually got these new buttons. The user allows me to register on the site. I've obviously registered already, so I'm just going to sign in. Having signed in, we can see the information about me from my biography, but you can also then go to the detail if you want to. You can change your avatar, you can go and set the settings for this user. Having logged in, we can then go and search, and we're seeing here some tasks of mine that I've uploaded. Here's a task of someone else's. Now, that isn't mine. If I'm going to use that, so that's a public project that Mike has made available, but in order for me to interact with it and save back to it, essentially, I would need to fork my own copy. So that says fork and sync, so I can create a fork of someone else's project. I'll tell you more about that in a moment as well. If I carry on and start typing, let's go and search for something to do with dynamic. I've got a dynamic selective inspect. So this is one of my projects, I can sync that one. So I've just pressed sync. I'm going to create a folder where I want that to land on my local machine. Selective inspect, open that folder, and it's synchronized now. If we go and look at my folders, we can see in the demos, it's just fetched all of those files from the GitLab server. Really easy. Search, what folder do you want this to go to? Sync. And now if I go and open, that was a bit too fast, but what happened there was, having just done a sync, having fetched a project for the first time, if I've then gone to PsychoPy's open experiment button, I instinctivly just use the hotkeys, of course. Doesn't work very well when you're doing a screencast. When you open, it will automatically take you to that folder that you've just fetched, assuming that's probably what you want to do. And so we've just opened that experiment. We can now go and look at this. I'm going an extra step here because this is a demo that I kind of want to show you as well anyway. I think a lot of people don't realize how they can use PsychoPy for dynamic experiments. What I mean by dynamic, for things that are constantly changing. I think a lot of people are just like, stimulus, response, stimulus, response. And the fact that you can change things constantly opens up a whole world of studies. So this is a study that shows you how you could see someone's search patterns while they view an image. Okay, so I'm going to present someone with a photograph, and they've got an aperture that they're going to look through. They're going to move that mouse around. Let's say they're searching for the ball. It's relatively easy to do. I've got a target stimulus that just had an image in. Okay, it's called image file. It's set every repeat. We've got an image that's a mask. You can see the mask is a circle mask here. And I set that to have a position related to the mouse pos. So I've gone online, I'm going to run this study, and this one runs on your desktop or online. Now I'm moving my mouse around, this is in a browser, and I'm searching for the ball. Okay? I've got 3 trials where I'm doing that for you to get some idea of how a task might work. But let's say, I didn't show you the second step. Go and download the demo and see, and run the second 3 trials where you'll see how that worked, because it's basically, in the second 3 trials, I just shrink the mask down so you can see what it looked like, and then it's actually quite clear. It's just really simple. There are just 3 objects in this trial, but it creates quite a complex and rich experiment. Okay, forks. I mentioned that I can fork someone else's project or sync my own. Forking, for those of you who aren't used to Git and GitLab and GitHub, forking is this notion where we can take an existing project that's public, and I haven't got write permissions to someone else's project, but I can take a copy of their project. The fork maintains its relationship with the original, so it knows that it came from someone else, and the other thing knows that it has been forked. Okay, so we are tracking the provenance of your study. We know where it came from and where it's going to, unless someone deliberately chooses not to. They could always, if you make your study public and someone really deliberately wants to hide the fact that they forked your study, they would be able to. But I think that's not where most problems occur. I think most problems occur because people let's be polite and assume that most of this is unwittingly stealing someone's experiments. This is maintaining that provenance. You could then fix things and push it back to that other person's study. You can help someone and build on someone else's study as well, right? This is really great for science, being able to make better studies and build on previous work. You can also like things within the project, within the repository. So you could find other people's projects, you could give them a star, and that indicates that this project is a useful one, but also the number of forks. So suddenly we can then start to prioritize the experiments you find according to how many times they've been forked or how many times they've been starred. You might be starting to realize that this might be a good thing for you, right? If you write a project that's useful to other people and you share it, other people are going to talk about your project. other people will fork it, other people will star it, and that, rather than being sort of concerned that people are living off your hours of work, this is great because it's increasing the publicity of your study. And hopefully this mechanism will provide another way to make that a little bit more clear that that's what's going on. Just in case that hasn't sunk in. You want people to base their work on your work. That's why you write the paper. Okay? But for some reason people think, oh, well, I should write the paper, but I shouldn't share my study. You should share your study because it makes it more likely that people will base their work on your work, and that is what you want. Okay. So, we can log in, we can search, we can sync. That's all fairly easy. How about uploading my own? So I've got a Posner task here. You can see the folder with the experiment. I've got a subfolder called images, and I've got some images inside there. Posner task, it has a, what am I off to? Oh, I'm just loading that experiment. The Posner task has a queue. Oh no, I've done it again. Posner task has a queue. No, stop doing that. Turns out, there we go. A queue that is an arrow that points to the left or to the right. That was in that images folder. It has a circle that's the target that appears on the left or the right. It's all fairly straightforward. Something that's a little bit new in recent versions of PsychoPy. I'm going to use the mouse to pause it instead of the space bar because that doesn't work. So a new thing that we've had in PsychoPy just recently is that your mouse object can now have clickable objects assigned to it. So when you want a stimulus to be clickable, it essentially becomes a button. You can have as many buttons as you like. So in the Posner task, we want to make our target clickable, and the way that our participant is going to respond is to press the target as quickly as they can. I used to use the keyboard, but now we're online, we need to make it possible for your tablet to run the task as well. So we need a mouse, and a surface is going to look like a mouse, right? So a screen click. So we've now got a stimulus that is clickable, and the trial will end when someone successfully hits that target. Rather than clicking anywhere, they've got to click on the target in order to force the end of the trial. So that's how this version of the Posner is going to work. So just a... Okay. So I want to push this study online. I've gone to press sync. I'm already logged in. I've gone to press sync. It said you need to create a study, a project online. So I'm going to create the Posner task. I'm putting it in PSJ, but you might have other groups, your lab group or whatever. I'm giving it a brief description. This task was in Builder, it wasn't in Coda, and it is going to work online. I'm not going to make it public for now. Now this is, so I've pressed sync, I've created my project online, and the first thing it said is, this is your first commit. Commit. It's Git, it's a version control system. It's not just sort of synchronizing like Dropbox permanently, constantly. It's waiting until you tell it, I want you to synchronize the set of files that I've changed. Okay? So this is the first one. We've added 6 new files. Well, it was a new project. So it's found 6 files and it's adding those to the project. Okay, so that's the first commit. And it's synchronized. That was it. Now I think this goes wrong at this point. I'm going to add a new file here. I'm going to add a Readme file. Always good to add a Readme file to your experiment. Now I'm just going to reopen that. When I reopen it, the Readme file comes up. Okay, this is another feature of PsychoPy that I think many people don't realize is there. If you put a Readme file next to your experiment, every time you open that experiment, the Readme file appears by default. You can turn it off. That's useful, again, it maintains the provenance. Here I've got the references for this task. So you can see the history of who that task has come from, if I've typed it in there. You can also leave reminders to yourself. Have you ever had that study where you've presented some audio stimuli and you've gone to the participant at the end and they've said, was there supposed to be something coming out of the earphones? You can leave yourself a note to turn on the audio amps. All right? Really useful. You could leave, maybe you need to keep a log of the changes that you made, because you're not using version control. So you could keep a log of the changes that you've made. Did you collect that participant before or after you changed the stimulus timing? If you've always got a text file coming up here, it might cause you to remember to type those sorts of things in. So you just drag readme.txt next to your experiment and it'll appear all the time. It's a really useful feature. Enough about that. So I've added a file. I'm going to sync. It says new, one file, summary of changes, added a readme. And I can press OK, if I can hit it, and we've synchronized again, and it's gone to GitLab on Pavlovia. Okay, now I want to export the HTML as well. This is a bit similar to those of you who've been using it already. So that isn't yet runnable in a browser. It's just a Python file still at the moment. We might make it so that when you press sync, it automatically does the HTML export. So far, right now, you've got to choose to export the HTML code. So I've gone File, off the top of the screenshot there. I've gone Export HTML. There's a red warning box still to say, this is all very new, be careful. You should be careful. It took a few seconds to generate that code. Now if I go back to that folder, we've got HTML, we've got index.html, Posner.js, and we've got a resources folder. For those of you who are trying the proof of principle version, this is all changed. It's not compatible, but B, it's all changed. But we added in there all of the resources, the images, the Excel files, and the necessary JavaScript. Now I've gone back and pressed sync again, added the HTML files to run online. Okay. I'm just going to go back and show you what's happened in my PSJ. You can see the description matched the same now as mine was. Now if we go to GitLab, to the project on GitLab Pavlovia, if we scroll down, you can now see all of those files are there. My README file is there. We can go and look at the commits. And you can see the series of actions that I've taken to get to that point, okay? You can see the development of this project. I think that's a really useful thing for your experiments. Incidentally, PsychoPy experiment files are text. They're just an XML file, really, underneath. So they work really well in a version control system. Even if you're both editing them at the same time, like your supervisor and you have both tweaked the experiment at the same time, if you've tweaked different bits of the experiment, it's still fine. You can change the instructions, they can change the target, and Git will just merge those together without a problem. If you change the exact same line, there's going to be a problem, but we'll have to think about how we're going to deal with that. But yeah, all of this, because of Git, is just super powerful. All right, so now we can see our history. You can also go and see the changes that you made in each one of these commits. You can actually track what happened in your study. Okay, that's my little girl. I blinked and forgot to explain what just happened. There was a fairly critical step just there. Okay, I've gone back to my task. I've gone and pressed run. It's taken me online, and my study is running. Okay, I can now go and start my study, and I've got to press my buttons as fast as I can. And it would look essentially identical if I were running the study in my lab. Okay, it works, mostly, I think. Right. Now, I did break this just before the talk with one of those git merge conflicts. But I think we could go and run this study. If you go and you should be able to get this to work on a browser, on any, like on your phone. It might look a bit weird, rotated, whatever. Let's try and collect a bit of live data and see what happens. So when you go into the ID, it'll bring up an ID. It'll bring up a dialog box. You need to give your participant. Don't type in your name, okay? Or if you do, it's not very easy for us to remove that. So call yourself something else. But if you like to, call yourself something that you'll then recognise when it comes up. All right? So you can go and run this study. Maybe I'll just do it quickly myself as well. Why not? Just make sure. I'm going to call myself Banana Face. Oh, Banana Face, fine. That'll be close enough. Now, we've never run this number of participants before. There are so many ways this could go wrong today. Okay, miss, quick. Okay, hopefully that worked. I'm going to escape. Moment of truth. I'm going to go to GitLab Pavlovia. I'm going to, what am I going to do? Search for Posner. Oh, Ponza. Demos Posner. Let's see what just happened. Data. We just got whole like there's a willow and a thesis. There's a banana face. All of your files just got pushed into that folder. It totally worked. What I would then do from my desktop, I would go to that experiment. I would press sync again. I'm not going to do it now because I've disconnected from it. But I would go back to that experiment in my on my desktop. I'd press sync again. All of those CSV files would be sitting there in my data folder, just like I had run my experiment at home. Yeah.
Doesn't work on Safari, it seems.
Oh.
Works on Google Chrome iPhone.
Yeah.
I have used it on Google.
Chrome, it works fine.
Yeah. We'll have to find out about Safari. It might be that it's sized strangely, or there are certainly, we're going to have to work out some of the glitches for the very many different combinations of phones and whatevers. Okay, whew, it worked. I'm going to say it. I'm going to say it worked, even if it didn't work for Safari. Timing. A lot of people have been asking, how's the timing going to be? And the first thing to say is not as bad. I didn't want to start this project in the days when you couldn't really do good timing. That was people have been asking for probably 10 years, could I run my study in the browser? And I've always said no, because the browser is not a sensible place to run timing studies. I do think that's changing. It's certainly not as bad as you think. So, what do I mean by that? The first thing that most people think is, what happens if I have a bad internet connection? It'll take a while for your study to start. Did you know when you started that study, there was a progress bar at the bottom while you were typing in your name, hopefully not your name, it fetched all of the resources for your experiment. They were downloaded to your browser. They were on your local machine. By the time you pressed OK, they were there, and then it was just, so the browser is like an interpreter, okay? It's got the resources, it's not fetching them as we run. We might change that a little bit when you've got movies, because maybe you don't want to wait for all of the movies to download entirely. We'll have to look at that when we get to it. But first thing, timing of the reaction times and the stimuli isn't going to depend on your internet connection. When your study's done, it pushes the data back to GitLab or Pavlovia, and we can synchronize it from there. We've been doing timing tests using a black box toolkit, measuring exactly how long does the stimulus last on the screen, for instance. And we've been whacking keyboards with a black box toolkit robotic actuator to see exactly how variable the response times are. Short answer is that the visual time, and much like in PsychoPy, the visual stimulus timing is really good. I would really strongly recommend for short stimuli that you request your stimulus to last a certain number of frames, not a certain duration in milliseconds. But we tested that, asked for a stimulus to last for 6 frames, and it lasts for 100 milliseconds on a 60 Hertz monitor. Exactly 100 milliseconds. What that means is that we are correctly synchronizing our stimulus display to the script, right? So when you say 6 frames, you get 6 frames. And assuming that your screen refresh is constant, which it almost certainly will be, you'll be fine. On your desktop, we also know about the absolute latency. So we can say, send a trigger to your EEG system, and we know that your stimulus will occur within a few milliseconds of that, depending on your monitor. But from the moment that the stimulus comes out of the graphics card, and the moment that the parallel port signal is sent, we are within a few milliseconds. We don't know about that for the browser, because one of the problems with the browser is that it doesn't have the hardware interfaces that we would need. We can't connect to the parallel port from a web browser, and therefore we can't right now say what was the T0, what was the start time from which we... But what we can say is that if you ask for 100 milliseconds or if you ask for 6 frames, you get 6 frames. So that's a good start. Reaction times, this kind of maps onto what other people have found with other libraries, although I think we're going to be able to do better soon. So don't take this as read for now. Right now, what we're finding is a lag in the reaction. So this is from the stimulus display to the detection of the robot whacking the key. We've got about an 84 millisecond lag with about a 3.5 millisecond variability. On your desktop using PsychoPy, using IO Hub connected to PsychoPy, you would get a mean reaction time lag of about 23 milliseconds. So that's the keyboard problem, with a variability of about 3.5 milliseconds. We think we'll be able to do this a bit better. I don't know if we'll squash that 84 milliseconds completely down to 23, but we think we'll be able to do a bit more with that yet. There is some more testing to do. Sounds, it's going to be worse, almost certainly, and it's going to be much more variable from one machine and one browser to the next. And so, not ready to tell you any answers. The brief story is that similarly we're looking at something like 90 milliseconds at the moment, but, i.e. 90 millisecond lag, but that's going to be very variable from machine to machine, and we're just going to have to see what that's like. So, essentially, you could still certainly use this to measure reaction time dependent measure, because the variability in these reaction times is about the same as your desktop. You can't connect to a button box, so you can't do this isn't going to be any good for EEG studies, all right? But it's going to be fine for most other things. A little bit about the future, what we're doing next. A lot of the features of PsychoPy are already working in PsychoJS. So most of the goodies of your builder experiment, your nested loops, your blocked experiments, all of that sort of thing, that should just work. Might not, but it should just work. We're able to run block design tasks, and we've tested that all those things are doing fine. Updating your stimulus on every frame. You've seen me moving a cursor around on every frame, and track, depending on where they're moving their mouse. Code components, they should also work. Well, let me just show you how that's going to work, or how that does work. Right now, if you add a code component, there's a new box here that's called code type. If you just say Py, it's just going to be Python code. But you could have JavaScript or both, and now you need to type in your Python code on the left. Let me go and fetch. Did I have it already? Let's see if I can fetch the nav on task quickly, because that included it. Demos. Oh, I've got a folder there already, but I don't know what state that's in. Call it nav on 2. Open. Didn't sync, maybe. Oops, not run. Don't run. Run was not what I was aiming for. Sync. Okay, open. No, it hasn't gone there. Oof. That was a fail. Should have been really easy, that part. Let me try opening the other one, see if that was actually... It might be that I didn't have permissions there. So, feedback in the nav on task. We've got, those of you who used PsychoPy before, we've got this sort of thing before. Can I make that bigger? Oh, I haven't got the JavaScript version here. What you end up with is something here that has to be valid JavaScript, so it's something like if resp core greater than 0, brackets, open curly brackets, / is the comment. Okay, there's going to be a little bit of converting your code into JavaScript. For now, we hope we're going to do a fairly good job in the future of doing that conversion for you. But right now, it's a matter of going into your code component, finding out what is the appropriate JavaScript. But like PsychoPy and its code components in the past, it's better to go in and write the code component than go and hack the script. I'd say it's better to do the same here. Like PsychoPy and Python, you can go and look at your script and go and see what the code objects are and see, well, what would happen if that were different, but then try and take those concepts and plug them back into your code component instead of leaving them in the compiled script. Sounds, we've got those added. I'll need to check with Alan whether we've got the file sounds. Certainly it was able to go beep, and you could choose your beep. You could play a note. As of very recently, you weren't able to play waffles, but there's going to be really, really soon if it's not done already. URL forwarding. At the end of if you're using Sonar for recruitment, or mturk, or prolific academic, we recommend not mturk probably, then you'll need a way to forward back to Sonar to tell the system that your participant completed the study. Okay, those will be built in very soon. They're not quite ready yet, but that will be that's nearly done. Also think that something else that is built in already, if you've got something that's going into your info dialog box, your participant, your session, your group, whatever you want it to be, that can also be passed in the URL as a standard URL query. So if you want to send out an email, right, when you're going to launch your study, maybe I didn't make that very clear before. Let's say we're going to launch our Stroop study. I'm going to send that to my participants, but I might also want to add information here about what group they're going to be, and when we do that, about what their participant is, and when we do that, it will automatically then populate these fields of the dialog box. And that's going to be important if you want to control. You don't want the participant to type in their name, okay? You want to give them their ID, and so you'll want a system to do that via Prolific Academic, give them an ID, and you send the ID back to Prolific Academic when your experiment is done to say that that participant completed. Okay, other stimuli like movies and that sort of thing, all of those I really expect will be very quick. Now we've spent a lot of time working on the server in the last 6 months, and also Alain and Francois have rewritten the JavaScript pretty much from scratch. So next stage, adding further stimuli should be really easy. I've said that once before, but I think this will happen quite quickly from this point onwards. Okay, there was a question about sustainability. Is this thing still going to exist? We've got 2 years of funding, and we do need to find a way to make sure it exists after that. PsychoPy will still be completely free, completely open source. It's going to be the same. I'm still hoping that other people will continue to contribute in the way. We've got 90 or so people that have added some sort of code or other, or helping out on the forums and that sort of thing. It's a great community at the moment, and I'm really hoping that will continue. I'm hoping that having professional staff won't damage that. On the other hand, I'm hoping that we get to keep David in a job and Elixir working on this as well, because the rate of progress in the last 6 months has been much, much faster. After summer 2019, we will start charging for running participants on Pavlovia. Okay? We're going to be charging a really small fee. We've got a lot of users. I'm hoping a lot of users will start using this platform. And if we've got a lot of users, we only need to charge them a fairly small fee. I'm thinking pennies per participant or 20 quid for a study. That's kind of in my head. But we're going to explore exactly what the pricing method will be as we know how many users we've got. And to survive, to answer that question, will the server still be there? The amount of money that we need to generate in order to keep the server in existence is tiny. Server costs are very small these days. That shouldn't be the problem. The problem is, do we have staff to keep fixing bugs and making things better and adding new features? And for that, we do need a reasonable number of participants, users, people getting involved and running their studies here. So go and tell your friends, if you like this stuff, and you find over the next year, you've got a year to play with it for free. If you find over the next year that you're liking this, get other people on board. The more people who are working with this, the cheaper and the better it will be for everyone. But as I say, PsychoPy open source, PsychoJS open source. If you want to run studies on your own server, I think we'll still be able to make that possible, although it's getting increasingly complicated what steps you're going to need to do. I would probably recommend just stick with Pavlovia, and also that means you're supporting the community. Pavlovia features, so we've already got all of that stuff from GitLab, groups, users, security, that's all done. Issues lists, wiki pages. If you know how to build in automated testing of your experiment, you can do that. It will help you with that. Very soon we'll have support for JS Psych and LabJS, and possibly others. I don't know what others there are, maybe there are. If you've got your own preferred open source software that you'd like to use here, then there's no reason that Pavlovia shouldn't work for all of those. It's not something that's to be tied to PsychoPy in any way. That's why we call it Pavlovia, not studies.psychopy.org. Okay. We're also going to be, so right now when your participant finishes, it saves a CSV file, puts it back into your data folder, with a git push. That's fine. I mean, in fact, in terms of analysing your data, if you've been using PsychoPy before, that's pretty convenient because you just carry on as you were before. There's a downside to that, and that's about GDPR. So GDPR requires that if you've stored personal data from your participants, caveat, there's a get out clause for doing research as well. But anyway, on the whole, if you've stored personal data for your participants, you need to provide them with a means to get rid of their data. And probably for your ethics committee, you've probably always been telling them as well, yes, we'll definitely provide a means to get rid of a participant's data if they want to be removed from the study. That's not great with Git, because once a file is in Git, even if you delete it, because it stores all of the version history, they're still kind of there, all right? You've not met your GDPR responsibilities there. So we will also be, if you didn't collect any personal data by accident, if you made sure they didn't type in their name as their participant ID, then you're probably fine. You could probably just use that simple method. It's very convenient. But otherwise, a database, an SQL-based system, which we will be supporting as well, is a better way of being able to remove an individual if you want to from that database, and remove them permanently with no history. Okay, so that's the other side to this. But it's a little bit less pleasant for you extracting your data. We'll have something so that right now when you go to that project in the Explore, you can activate your study, you can view your project files, you can run and you'll be able to view the data there as well from a database scenario. So that's another system. There are going to be some teething issues. A couple of them I've run into today. And yeah, this is 7 months into a 2-year project, just to say it again. I think we've done very well for a 7-month project, but there are lots of things that are going to be some wrinkles for a little while, I think. Because we've got staff working on this full time, not just me in between lectures, we'll be fixing these issues much faster, but there are going to be some issues. So these are some of them. GitLab and Git permissions. I expect, so this wasn't too hard for me because I've already used Git on my computer for a while. You need to install Git on your computer. That's the first step. I should have mentioned that one. You need to install Git on your computer. I think right now PsychoPy is not probably going to even run if you haven't got Git on your computer. It's not going to give you a nice error message saying you should install Git. Beta 2 will give you an error message that says you should install Git on your computer. There are going to be problems when it turns out that you haven't set Git up with your permissions and that sort of thing. We're trying to do that for you so that you don't have to worry about it too much, but we might have some problems with it. Git sync, each time I pressed sync there, what that was doing was pulling the latest changes from the server and pushing the latest changes to the server. That is going to be fine while there aren't any conflicts, and Git is pretty good at avoiding conflicts. But once in a while, you will both change. Someone will delete the data folder while someone else tries to add a data file to it. And that is a blatant conflict that can't be fixed. So right now, we'll just fall over because Git will have a merge conflict. Unless you know what you're doing with that, that's going to be a problem. So we're going to be working on ways to get around that for people who aren't familiar with Git and aren't used to this sort of system. We'll need to do something more like Dropbox, where we say, okay, there are 2 files, they conflicted, we'll create multiple copies of them and leave it to you. And let's face it, what you're going to do is just leave both of them saying conflicted. That's what I think happens on Dropbox. You just leave 2 copies because you don't know what to deal with. That's what's going to happen. Stimulus scaling and units. You know, PsychoPy is designed for running in a calibrated lab scenario. suddenly you're running your studies with all sorts of different shaped devices and pixel sizes and whatever. So suddenly there are going to be some problems around that we've not had to solve before. If you're going to run your study online, probably use height units or norm units. If you don't know what those are, go and check the PsychoPy documentation. Height or norm allow you to rescale according to the size of the screen, rather than it being a certain number of pixels. So if you're going online, probably those two units. But I suspect we're going to need to come up with something new as well. I think probably we'll need to rethink this from scratch, and if you've got ideas about how that should work, that would be awesome. Right now, the error messages aren't that clear. As I say, if you don't have Git installed, we'll just crash right now. But those will be getting better in the next few weeks for sure. And here's another interesting problem that we've realized is probably going to bite people quite a bit. You change your study, and then you go and reload it in your browser, and it hadn't changed. Two problems there. One is that right now, as I say, we require you to export your HTML files each time you want to. And we'll need to change. It's a bit like in the old days when you press run in PsychoPy, if you hadn't saved your experiment, it ran the previous version, and it now says, would you like to save your experiment? It's that. So one step is that will probably prompt you that you should export your export your HTML again. But there's also a problem. It turns out that when you reload in the browser, it doesn't necessarily reload the JavaScript. So you might also have to do a forced reload where it reloads the JavaScript as well. Keep up to date. All of this is going to be changing quite a bit still in the next few weeks and months. So keep up to date. Go to discourse.psychopy.org. Make sure you're watching, or watching first post at least, for the announcements and the online studies, because we'll be posting, oh, we've just discovered this. There's a new version coming out. We'll be releasing quite a few new versions in the next weeks and months. So, just to summarize, I hope that PsychoPy, for a long time, has been useful to the scientific community by enabling people to run their studies, enabling people who previously couldn't create a study to be able to create one. I think it also helps, I hope it also helps, by encouraging people that actually a bit of Python code, not a bad thing to learn, and making it maybe a little bit more accessible, that these are useful tools, and with a few lines you can get started without having to code an entire experiment. So I'm hoping that PsychoPy has done that a fair bit already. I'm hoping that Pavlovia is going to push that into another level as well. So partly, great, let's enable experiments to be run online. A lot of people right now would like to run a study online and don't know where to start. Hopefully at least you can see here there's a way to start. I'm hoping that we're going to encourage more open science by encouraging sharing, because there's going to be a repository of studies that hopefully will get quite big quite quickly. You're going to find it very easy to find things, and maybe you're going to think, oh, maybe I'll share things too. So, I mean, I'm probably the people who are here and people online watching this, you're probably already the converts to that world, but hopefully some more people are going to start seeing that as a way to behave scientifically. And I'm really hoping that, you're going to start a bit like with Builder. You'll start off just creating your study and pressing run, and you're going to start thinking, it seems like there are some other features, and you learn to program a little bit in Python. I'm hoping that you'll start to press sync and commit, and that you'll start to think, maybe there's something more to this version control system that I might be able to use. So you might start creating branches of your experiments and all that sort of thing. Okay, I'm nearly done, and my voice is about to give out. So, thank you to the team. I'm John. I didn't say that, did I? I'm John. And David Bridges has been working on the the system here. He's responsible for most of the builder to JavaScript outputs, and will be very heavily involved in the support forum and the testing over the next few months. Alan has been responsible for the majority of in fact nearly all of the Pavlovia development, and Alan and Francois between them were writing the JavaScript code. Francois initially for version 1, and Alan since then largely. But also a very big thank you, of course, to the community, because it's all of the early adopters, the people who've tried this and gone and found bugs, gone and found improvements to the documentation, and we depend on all of those. And also to the rest of what would PsychoPy be without NumPy and Piglet and OpenGL? So there's a huge number of open source developers that we depend on in this community, and it's going, I think it's a really strong thing. Also thank you to the Wellcome Trust and to the University of Nottingham. So thank you as well.